Hello again, algebra students. So here is part 3 of section 11.2, simplifying radical expressions. In part 1 and part 2, we talked about the first condition being met, no perfect square factors in the radicand. In part 3, we're going to talk about the next two. So no fractions in the radicand, no radicals in the denominator. Those are two other conditions that would put a radical expression in simplest form. So we're going to use one other property called the quotient property of radicals. It basically says that the square root of a quotient or a fraction is equal to the square root of the numerator and the denominator. So right now, square root of 4/9 is not simplified because we have a fraction in the radicand. So to simplify this, we take the square root of the numerator, square root of the denominator, and then we simplify those square roots. Luckily for this one, square root of 4 is 2, square root of 9 is 3. Both the numerator and denominator are perfect squares, so that just simplifies to 2/3. Here's another example. So again, we're looking for no fractions in the radicand, no radicals in the denominator. To simplify this, we just break it up. We take the square root of the numerator, square root of the denominator, square root of 16, that is equal to 4, square root of 25 is 5. So the square root of 16/25 is equal to 4/5, or would simplify to 4/5. Now, the question has to come up, well, what if they're not perfect squares? Well, we just simplify the radicals like we normally would, like we learned in part 1 and part 2. Break it up, make sure there's no perfect square factors under the radicand. However, the third condition was we can't have a radical in the denominator. So in this one, if we break this up, take the square root of the numerator, square root of the denominator. Square root of 4 is 2, but in the denominator, we can't simplify radical 5. Not a perfect square, but we also can't have a radical in the denominator of our fraction. So what we're going to learn how to do is called rationalizing the denominator. So to eliminate a radical from the denominator, here's the example we're using. 5 over radical 3. We're going to multiply by a form of 1, and I said appropriate form of 1 because it has to get rid of this radical. Okay, so the form of 1 that we're multiplying by is right here. Whatever this denominator is, that's what you multiply by in the numerator and in the denominator. So here's our form of 1. The reason we're using 1 is because if you multiply any number by 1, it doesn't change the value of that number. So we're going to multiply this fraction by 1, basically. Even though it looks like radical 3 over radical 3, that's still just equivalent to 1. So when we multiply in the numerator, 5 times radical 3 ends up looking like this, 5 radical 3. Radical 3 times radical 3, we're kind of using our product property of radicals from part 1, part 2. Radical 3 times radical 3, that's radical 9. And we can simplify radical 9. We can't do anything with radical 3 up here. There's no perfect square factors other than 1. So numerator stays the same. However, denominator, square root of 9 becomes 3. So this would be the simplified expression. That's called rationalizing the denominator. Multiplying by an appropriate form of 1. That form of 1 is just whatever the denominator is in the numerator and the denominator. So let's go back to our 4/5. We've already broken it up and said that it's 2 over radical 5. So now we need to rationalize. So we need to multiply by that form of 1, which would be radical 5 over radical 5. And then we multiply. 2 radical 5 times radical 5 is 2 radical 5. Radical 5 times radical 5 is radical 25. And then we simplify. So 2 radical 5, nothing to simplify there. Radical 5 is simplified, doesn't have any perfect square factors. Square root of 25 is 5. And then always look at these numbers. Treat this as a fraction of its own. So 2/5, and see if you can simplify that at all. We can't simplify it. However, if it was like 2 over 8, we could simplify that to 1 and 4 in the denominator. So be careful with that. Other than that, that is how to rationalize the denominator. So let's practice. Well, 2 over radical 5, we just did this one. It started out a little bit differently, but let's just do it again. So rationalize the denominator, multiply by a form of 1. There's our form of 1. 2 radical 5 over radical 25. And as we saw, it simplifies in the denominator to just 5. Now let's kind of throw everything together a little bit. So now we're looking to simplify, and we're looking for all 3 conditions to be met. No perfect square factors in the radicand, no fractions in the radicand, no radicals in the denominator. You have a couple options here. If it's radical 5 times radical 30, we could multiply those things together, get one radical, and then work on simplifying that radical using everything we've learned so far. Or you could simplify each radical and then multiply them together after you simplify, and simplify even more if you need to. I tend to prefer option 1. So I'm going to show you option 1. I'll show you option 2 on another one. So option 1 says multiply these together. 5 times 30 would be radical 150. And then I would simplify that. So radical 150. There's no variables, there's no fractions, nothing. All I'm looking to do is get rid of perfect square factors. So I'm going through perfect squares, and I'm figuring out what's the biggest one that I can divide by. I believe it's 25. So I'm going to break this up into radical 25 times radical 6. Radical 25 simplifies to 5 times radical 6, and that would simplify it. Here's another one. This one is a good one to look at option 2. So option 2 says simplify each one, then multiply them together and simplify any more. So radical 50, if I work on simplifying that, I could break that up into radical 25 times radical 2. For square root of 18, let me use a different color. I could do 9 times 2, so radical 9 times radical 2. And then simplify each one. So radical 25, that would give me 5 radical 2, so that's what square root of 50 would simplify to. Multiplied by square root of 9 is 3 times radical 2, and then I could multiply them together. Gets a little tricky here because we haven't really talked about multiplying things like this, but basically you multiply the things on the outside together and the things on the inside of the radicand together. So 5 times 3 is 15. Square root of 2 times square root of 2 is the square root of 4. And then I have to simplify a little more. So square root of 4, I know that's 2. So this should just be 15 times 2, which is 30. So that's option 2. If you want to see option 1 would mean we have to do 50 times 18. We just multiply them together first. So 50 times 18 is 900. So we would get radical 900, and then we would work on simplifying that. The issue is that's a huge number. It might be difficult to find perfect squares of that big of a number. Luckily, it ends in 2 zeros. It's not that bad. If I'm thinking square root of 9, I know it's 3. And with the 2 zeros, I know that each of those have to have a 0 on them. So it would be not square root, it would just be 30. So again, if you multiply and get a really big number, option 2 might be a better option. Simplify each one individually and just kind of gradually, step by step, work towards simplifying the entire expression. Let's throw some variables in there. Here's one, numbers are not too big. I think I would definitely go option 1. So I would multiply. And in fact, if we want, you might even want to break this up into numerical part times variable part of the radicands. And then we can just kind of change the order around, put the numbers up front, put the variables at the end. Multiply 14 and 2, that would be square root of 28. Multiply x and x, that would be square root of x squared. So square root of 28, simplify, look for perfect squares you can divide it by. I think the biggest one is 4. This would be radical 4 times radical 7. I'll just drop down the radical x squared. Radical 4 is 2, so square root of 28 becomes 2 radical 7. Now I just need to simplify the variable part of it. And I have an even power. That means it's a perfect square already. So this is going to be multiplied by square root of x squared would just be x. And then again, just rearrange, write it the appropriate way. So the x would go alongside the 2. It's outside of the radicand. 2x radical 7. One more, a little more complex, and we'll finish here. So numbers are not too big. I think I would multiply everything together here. So let's split everything up. Let's split the number part up. Let's split the variable part up. Times, and I'm going to do this part in blue, 4 times radical 3 times radical x squared, just so you can see where everything is coming from. And then I'm going to multiply kind of everything that's similar. So like the 3 and the 4 are outside of the radical. So those things are going to be multiplied together. Then I'm going to look at my radicals. I have a radical here that's just a number, another radical that's just a number, so I'm going to multiply those. Radical 8 times radical 3. Right now I'm just changing the order. And now variables under the radical, I'm going to put those next to each other because I know I can multiply them together. So now let's multiply. 3 times 4 is 12. Radical 8 times radical 3 is radical 24. Radical x to the 5th times radical x squared. Use your properties of exponents. X to the 5th times x to the 2nd. We add the exponents. That would be radical x to the 7th. Now let's simplify each radical. So the 12 is just staying on the outside. Square root of 24. I can divide that by 4. So that's radical 4 times radical 6. I'm not going to do anything with the variable yet. Square root of 4 is 2. So this becomes 12 times 2 times radical 6. Now let's focus on the variable. Go ahead and multiply 12 times 2. That's 24 times radical 6. It's odd. So the biggest even number would be to the 6th power. So this is x to the 6th times radical x. 24 times radical 6. Square root of x to the 6th. Remember, half the exponent is the perfect square, so this would be x to the 3rd times radical x. And now everything is simplified. I just need to rewrite it in the correct order, in the correct way. So everything that does not have a radical, I'm going to put out in front. 24 x to the 3rd. Anything that does have a radical, I'm going to multiply those and put them under the same radical. So 6 times x would be written as 6x. So final simplified expression would be 24x to the 3rd radical 6x. I know that was a lot. There was a lot to that because we were putting everything that we learned together and a little bit more from part 1 and part 2, but I hope this helps you simplify radicals using all 3 conditions as well as rationalizing the denominator. Have a great day, guys. Good luck on your assignment. Let me know if you have questions. Email me, and I'll do my best to help. Have a great day.